Welcome to the spoken tutorial on plotting 2D graphs with Scilab. Assuming that Scilab is installed on your computer, we will discuss plots in Scilab. Scilab offers many ways to create and customize various types of 2D and 3D plots. The several common charts Scilab can create are XY plots, contour plots, 3D plots, histograms, bar charts, etc. Now open your Scilab console window. I will use plotting.sce file to cut and paste the commands. In order to plot, we need a set of points. Let us create a sequence of equally spaced points. This can be done by the linspace command, which creates a linearly equally spaced vector. For example, x is a row vector with 5 points linearly equally spaced between 1 and 10. Similarly, y is a row vector with linearly equally spaced 5 points between 1 and 20. More information on linspace can be obtained from the help documentation. We will now plot a graph with argument x and y using the plot function. This is similar to the one used in MATLAB. Plot x, y creates a graph of x versus y, as you see. Notice that the graphics window is labeled as 0. We will open another graphic window using the xset function. I will close this, cut the xset function, paste in Scilab, hit enter. You will see a graphic window number 1. Note that 2 arguments are passed to this function, namely the window and 1. The next graph will be plotted on this window. For Scilab, plot 2D is the native function used to plot 2D graphs. Plot 2D command plots a graph of x versus y, as you see. Notice that there is a third argument called style. Style argument is optional. It is used to customize the appearance of the plot. For positive values of style, the curve is plain with different colors like green for 3 in our case. The default value of style is 1. Try plotting graphs for negative values and see the difference in appearance yourself. Also, we can set the start point and end points for x and y axis by passing the fourth argument. It is called rect. As you see, we have x-axis starting from 1 to 10 and y-axis from 1 to 20. The order of arguments in the rect command is xmin, ymin, xmax and ymax. Let us now learn about title, axis and legends. To configure label to the axis and title to the plot, we can use the commands title, xlabel and ylabel. I will cut this set of commands and paste in the console. Hit enter. You will see that the graph has been labeled x to the x-axis, y to the y-axis, and the title of the graph is my title. You may want to configure the title and axis of the plot in a single command instead of 3. For this purpose, we use the xtitle command with all the 3 arguments. I will cut this command, paste in Scilab, enter. Now you see that the x-axis label is x-axis, y-axis and the title is my title. The CLF function that I am typing now will clear the graphic window, as you see. It is useful while plotting different graphs on the same graphic window. I will close this window. Sometimes we need to compare 2 sets of data in the same plot, that is, 1 set of x data and 2 set of y data. Let us see an example for this. I will scroll down We will define the x-axis points in a row vector x using the linspace command. Let us define a function y1 is equal to x square. Plot x versus y1. Define another function y2 is equal to 2x square. Plot x versus y2. We will also give the label and title to our graph. Notice that we have additionally passed 0 minus and plus minus command to the plot function to change the appearance of the curve. These arguments are not a part of plot 2D function. They can be used only with the plot function. I will copy this set of commands and paste in the Scilab console. You see the graph. Wouldn't it be of great help to know which curve is associated with which function? This can be achieved using the legend command. As you see. Zero minus curve represents function y1 is equal to x square and plus minus curve represents function y2 is equal to 2x square. I will close this graphic window. We will now discuss about plot 2D demos and subplot function. Scilab provides demos for all its major functions. Demos of plot 2D can be viewed through the demonstration tab. Click on graphics, click 2D 3D plots and select a demo out of the various demos provided. I will click on plot 2D. You will see a demo graph. The code for this graph can also be seen by clicking on the View Code button here. This link does not open in Mac operating system, but it works in Windows and Linux. Nevertheless, in Mac, the code can be viewed through a directory. Let us go to the terminal. Currently, I am in the demos directory of Scilab 5.2 as shown. The full path to this directory is shown here. We will type ls to see the list of demos available. As you see here. Then we will select 2D 3D plots directory and hit enter. Type ls again to see the various demo code available in the SCE files. We will view the code for the demo which we have seen earlier. Type more plot 2d.dem.sce and hit enter. Here you will see the code for the demo graph of plot 2D function. I will close the terminal. I will close the demo graph and the demo window. Similarly, you can go through the other demos and explore Scilab. Let us now discuss about subplot function. The subplot function divides the graphic window into a matrix of sub-windows. To explain this, we will use the demo for plotting 2D graphs in Scilab. For example, type plot 2D in your console and see the demo plot for this function. I will close this window. The subplot command breaks the graphic window into a 2x2 matrix of sub-windows represented by the first two arguments in the subplot command. The third argument denotes the current window in which the plot will be plotted. I will execute this whole set of commands by copying it to the Scilab console. You can see the 4 plots in a single plot window. The plot obtained can be saved as an image on your computer. Click on the graphic window, go to the File menu, select Export to, give a suitable title to your plot. Select a destination folder to save your file. select the file format in which you want your image to appear. I will select the JPEG format and click Save. Browse through the directory to open the image and verify yourself whether it has been saved or not. This brings us to the end of this spoken tutorial on plotting in Scilab. There are many other functions in Scilab which will be covered in other spoken tutorials. Keep watching the Scilab links. Spoken tutorials are a part of Talk to a Teacher project supported by the National Mission on Education through ICT. More information on the same is available on the following link. Thanks for joining. Goodbye.